Hello friends, in this video we are going to solve problems on discrete time convolution. Let us begin. Question number 1 is displayed on the screen. A discrete time LTI system has an impulse response h of n with h of 0 equal to 1, h of 1 equal to minus 1, h of 2 equal to 2 and 0 otherwise. So before we proceed with the question, let us write the given data one by one. So look at h of n, that is impulse response given, where h of 0 value is 1, then h of 1 is minus 1 and h of 2 is 2. Just to indicate it is h of 0, we put an arrow mark here, right? And it is 0 otherwise, it is given. So there are only 3 samples inside h of n. In fact, length of sequence of h of n is 3. The system is given an input sequence x of n. So we have input x of n with x of 0 and x of 2 equal to 1. So this is x of 0. The middle space is left for x of 1 and x of 2 is given as 1 and 0 otherwise. What does that mean? All other sample positions are put to 0. Again, an arrow mark can be shown here just to show it is x of 0. The number of non-zero samples in output sequence y of n and the value of y of 2 are respectively. GATE 2008 question it is. So ultimately, they are indirectly asking you y of n and y of 2. So we know the relation when x of n and h of n is given, and if you want y of n, then y of n it's simply x of n convolution with h of n. And you know that when it comes to discrete time convolution, the best way to do convolution is using tabular method, right? Let us begin with tabular method, we'll get our answers. So this side I'll take x of n, this side I'll write h of n. Let us write all the samples present in x of n. They are 1, 0, 1, and for h of n it is 1, minus 1 and 2. So you know what is the tabular method. So just go on filling whole table. You get 1, 0, 1 here, you get minus 1, 0, minus 1, and here you get 2, 0, 2. Am I right? Then we mark the diagonals. So within every diagonal, you have to add the element present in each diagonal and you have to write the final element. So let me write a final y of n now. See, from the first column or first diagonal, you get 1. So I can write 1 here, comma. In second diagonal element, if you add minus 1 plus 0, you'll get minus 1. So minus 1 is the next element, comma. Then 2 plus 0 plus 1 will give you how much? 3. 3 is the next element. Then 0 plus of minus 1, you will get minus 1. And last, we'll get 2. Is that right? If you remember, it was clearly mentioned that x of n having arrow mark here means x of 0 is having value 1 and h of 0 value is also 1. So taking their intersection, we'll get a very first element as y of 0. So let us get back to the question. So what they are asking you, the number of non-zero samples in output sequence y of n. If you count non-zero elements in y of n, you will see all elements in y of n are non-zero. So just count 1, 2, 3, 4, 5. So there are 5 non-zero elements and the value of y of 2. So you know that this is y of 0, this is y of 1, so this is y of 2. So what is y of 2 value? It is 3. And number of non-zero values are 5. So 5 comma 3 has to be answer. Option D is the correct option. Let's move to the next question. Given the finite length x of n and corresponding finite length of y of n of LTI system as shown below, the impulse response h of n of the system is. So in last question, you have seen x of n and h of n were given, and the question was related to y of n. This time they have made some difference. This time they have provided input as well as output, and they are asking you question based on impulse response. So we'll see how to handle such kind of questions. X of n, y of n are provided. The question is related to h of n, and the question is we have to find impulse response of the system. So small observations. If you see the length of sequence of x of n, I can say L1, which is equal to 2. You know that length of sequence means number of elements present in each sequence. If you see here in y of n, it is having 1, 2, 3, 4, 5. So I can say length of sequence for y of n is 5. We know that notation wise we use L1 as length sequence for x of n, L2 for having length sequence of h of n, and L for measuring length of sequence in y of n. So since h of n is question mark for us, we don't know what is L2, but then we know what is the relation between L1, L2 and L, and it is given by relation L is equal to L1 plus L2 minus 1. So value of L is 5, value of L1, which refers to length of sequence of x of n, it is 2 plus L2 minus 1. So 2 minus 1, it is 1, and then 5 minus 1, it is 4. So L2 will be equal to 4. We know that this L2 refers to length of sequence of h of n. Meaning that there are total 4 elements inside h of n. So on basis of that, I can eliminate option B, because option B says h of n is having only 3 elements, and option D also I can cancel. So the competition is between option A and option C. So we have to again see what is the correct option out of it. So what we'll do is we'll try option A. Okay, how to try option A? That you assume that this is the correct option, that option A is the correct option. So assume that x of n is given, and assume that this is h of n, and try to get y of n, and see to it whether you get the same y of n or not. If not, then option A goes wrong, option C must be the correct option. So let us try option A. X of n is 1 minus 1, and according to option A, h of n is 1, 0, 0, 1. Is that right? So now you can try a tabular method and see to it whether you get same y of n which is provided in the question. The arrow marks were given. So here I'll take x of n, I'll write 1 minus 1. Rest of the samples I'll write here, that is h of n samples 1, 0, 0, 1. So let us go on multiplying. 1 minus 1, I'll get zeros, again we'll get 1 minus 1. So these are diagonal elements. So you can write y of n now. So y of n, this is 1. Second element, if you see, it is minus 1. Third element is 0. Next element you will get 1, and last you will get minus 1. And arrow mark will be here only. And now if you verify, then it is not equal to the given y of n. Option C has to be the correct option. So according to option C, h of n is all ones. So if you want, I can actually try this option also. So again, checking for option C. So writing x of n here, 1 minus 1, and then all the elements here. Let us mark diagonal elements. So y of n will be, I'll get 1, then 1 minus 1, it is 0, 1 minus 1, again it is 0, 1 minus 1 comes out to be 0, and last element you will get as minus 1. And of course, you'll get y of 0 position here. So see to it whether you had same y of n in the given question. So we were sure. So option C is the correct option. Even option A gets eliminated. Option C is the correct option. Let's move to the next question. In fact, before we move to the next question, we can apply some alternative method also here. So we'll see what is alternative method. X of n is given to us, which is 1 minus 1. So we'll apply method 2 here. It was 1 minus 1. Is that right? And also y of n is given to us. Let me just write that y of n as it is. It is 1, 0, 0, 0, minus 1. And regarding h of n, we know only one thing, that is number of elements inside h of n, that is the length of sequence of h of n, which was 4. So in fact, length of sequence for h of n is known to me, which is 4. Therefore, I can assume h of n as all 4 elements are unknown to me. So I'll assign some variable a, b, c, d. Is that right? So in a way, now x of n and h of n is quite known to me, and let me get by convolution method y of n. That y of n I'll be getting in terms of ABCD. That y of n I'll compare with the given y of n and I'll get all ABCD values. Let us see. So I'll take 1 minus 1, that is elements of x of n, and then elements of h of n, which are a, b, c, and d. Just cross multiply. So this is a minus a. We'll get b minus b, c minus c, d minus d. Mark all the diagonals now. Let me write now y of n. The first element is a, comma, minus a plus b, or I can write b minus a, comma, I can write c minus b, comma, d minus c, and the last element is minus d. So let me just compare this y of n with given y of n element, which were 1, 0, 0, 0, minus 1. Don't forget, arrow marks are at same position. So this is given y of n. So by comparison, you'll come to know that a is equal to 1. Is that right? So this is how I'm comparing. First element is compared with the first element. Second element will be compared with second element. So I can conclude b minus a equal to 0. Value of a is known to me, which is 1. So b becomes plus 1. Next, c minus b is also 0. Again, value of b is equal to 1. Substitute over here. We'll get c equal to also 1. And last, I can compare d minus c with this element. So d minus c is also equal to 0. Value of c is 1. So value of d is also equal to 1. So if you remember, our assumption says h of n is a, b, c, d. Having h of 0 position here, I'll get 1, 1, 1, 1, 1. Is that right? So this is the another method to get h of n. So you can choose the method with which you are more comfortable. Let us move to the next question. Next question says x of n is equal to n when n is lying between 0 to 10. Okay, and it is 0 otherwise. If y of n is equal to x of n convolution with h of n, then the value of y of 4 is. So this question needs a small correction. Y of n is equal to x of n convolution with x of n. So the signal is getting convolved with itself. That's it. So from the description of x of n, I can say that it is this kind of signal which graphically I can draw now. So for n equal to 0, it is having 0 value. For n equal to 1, it is having an amplitude 1. For n equal to 2, it is having an amplitude equal to 2. Like that for 3, and so on. It will go up to 10. And thereafter, it is always 0. Even before this, it is always 0. So this kind of signal it is. So I can actually write x of n in the form of sequence like this. X of n equal to 0, comma 1, comma 2, comma 3, 4, and so on up to 10. Have an arrow mark here. So this is x of n given to me, and I have to convolve x of n with itself, and that is y of n. So they are not asking you complete y of n, but they are asking you the value of y of 4. Let us see how we can handle this. So we would not be doing something great, but to follow the same method, that is a tabular method. So here I'll write x of n. What are the values? 0, 1, 2, 3, 4, 5, and so on, going up to 10. And here I'll be writing same x of n, 0, 1, 2, 3, 4, 5, and so on up to 10. So just go on preparing the table. If you multiply 0 with any number, you'll always get 0. So in first row, we will have all zeros, right? Next, when you multiply any number with 1, it remains same. So we'll be getting 0, 1, 2, 3, 4, 5, and so on to 10. So multiplying with 2 will give you twice the number. So you'll get 0, 2, 4, 6, 8, 10, 20. So multiplying with 3 will give you 0, then 3, 9, 12, 15, 30. Multiplying with 4 will give you 0, 4. Let us see if this much is enough for you. We know that this is x of 0 position, right? So a very first element will give you y of 0. So this will give you y of 0. This gives you y of 1. This gives you y of 2. This gives you y of 3. And last, it gives you y of 4. Right? So we don't have to go on convolving everything. But then they're asking you only for y of 4. So let us get that much. Add all of them. And what you get? 3 plus 4 is 7. 7 plus 3 is 10. So the answer is 10. Right? Let's move to the next question. So in this question, they're asking you that x of n and h of n is not equal to 0 when n equal to 0, 1, 2. That is, let's talk about x of n. It means x of 0, x of 1 and x of 2 are non-zero values, and so h of n also. In fact, x of n value they have already provided us, that is 1 to 1. Then h of n value they have given, okay, not given completely but partial values are given, only h of 0 is provided, and value of y of n is also given you partially, and they are asking you the value of 10 times y of 3 plus y of 4. Okay, 2017 question it is. It is quite clear that if you want to calculate this, you should know what is y of n, right? And if you want to get what is y of n, you should convolve x of n and h of n. But the problem is x of n is given completely, h of n is not given, right? So let us see what we can do. Let me just write what is given. Value of x of n is 1 to 1. So let me tell you, it is given but not printed in the question. So the arrow mark is here. H of n is also having an arrow mark here. It is mentioned in the question. It is not printed here. So value of h of n is 1, and you see that next two elements are not given. Let me just assume as a and b, and finally you have y of n. This is also partially given. So a very first element is not given, so I'll assume this is okay. I cannot go for a because a and b I have already taken. I must replace with some other letters. So let me just go for x, y, and z, right? So I'll write x comma 3 comma 4 comma y comma z, and the arrow mark is provided here. So again, there is no other solution other than the tabular one. So x of n given as 1 to 1, then value of h of n is 1, then a comma b. So just go on applying the tabular method. So you get 1 to 1 here, you get a twice of a, simply a, then b twice of b, and simply b. Mark the diagonals now. So value of y of n can be written as 1 comma 2 plus a comma 2a plus b plus 1 comma a plus 2b comma b. Is that right? So you can actually compare this y of n with given y of n. So let me just write given y of n just below this. It is x comma 3 comma 4 comma y comma z. Is that right? So just by comparison, you will come to know the value of x is 1. So just compare element wise. X is equal to 1. Also, you can compare this 3 with 2 plus a. So if I say that a plus 2 is equal to 3, it means the value of a comes out to be 1. Next, you can compare this 4 with 2a plus b plus 1. So let me just write it like this: 2a plus b plus 1 is equal to 4. So value of a is 1, so this becomes 2. Then value of b is not known to me, but 2 plus 1 is 3, and 4 minus 3 is 1. So getting b equal to 1, right? So finally this is 1. Value of a is equal to 1. This has given me value of b also equal to 1. So just substitute value of a and b here. So a is equal to 1, b is also equal to 1. So 2 plus 1 will become 3. So value of b, this has become 3. It means I can say y equal to 3. And finally, value of z is equal to b, but b value equal to 1. It means z value equal to 1. Is that right? So now I can decode my y of n completely. I can write y of n as value of x is equal to 1, comma 3, comma 4. Value of y, I got 3, so I can write 3 here. And value of z is also equal to b, so it is equal to 1. And now finally I can go for my question. So what I need to calculate is n times y of 3 plus y of 4 is equal to n times y of 0, this is y of 1, y of 2, and y of 3. So y of 3 is equal to 3 plus y of 4, which is 1. So if you calculate, you'll get this as 31. So 31 is the correct option for this question, right? Let's move to the next question. So I'm sure you understood all the examples. In fact, discrete time convolution is very easy. While solving for discrete time convolution, you should know how tabular method works. If you are able to understand this tabular method very well, you are able to solve many questions which has come in gate. But then, of course, discrete time convolution is not just limited to this tabular method. There are many things to be learned which is related to discrete time convolution. That is what we are going to do in the next video lecture. Thank you.